All right, we are ready to move on to part B. I'm actually going to try to do a separate page here. Here we go. If I copy this and go to a new page, and then how do I paste, please? Sorry, this is my new adventure with the smart board. There we go. Okay, so we've got the same stuff here, and this time we're looking at part B. It says to use Mathematical Insight 2.1, and we're going to calculate the angular size of the planet. Angular size might sound familiar, and if you go and look at Mathematical Insight 2.1, this is where we learned that angular size is equal to the physical size times 360 degrees and divided by 2 pi times the distance. All right, well, we want angular size, so this equation's all set up for us. So that work is done at least. We just need to figure out what to put in for the physical size and for the distance. The physical size, it turns out, that's what we calculated in the part before. So physical size is 1 point, sorry, this is 1.23 times 10 to the 5 kilometers. And so now we need the distance. And the distance was given to us in this information part, 256 light years. So distance, 256 light years. But I have the physical size in kilometers, and I'd really like for these to have the same units since they're going in the same equation. So let's convert light years to kilometers. The conversion for that again is 9.46 times 10 to the 12. It's kilometers per light year. And so this is going to give us a distance equal to 2.42 times 10 to the 15 kilometers. Okay, so now we're ready to put everything into this formula. So angular size is going to be equal to the physical size, which was 1.23 times 10 to the 5 kilometers, times 360 degrees divided by 2 pi times the distance, which we figured out was 2.42 times 10 to the 15 kilometers. Okay, here's where you might want to pause, work this out for yourself, and then come back and we'll compare answers. So the kilometers are going to cancel, and we're going to be left with degrees, units of degrees here. And I get 2.91 times 10 to the minus 9 degrees. All right, this is a pretty small number. Does it have the units we want? Sometimes when a number looks really small or really big, it's good to go back and find out if we've got the right units. And actually, this question asks us to do this in arc seconds. So we need to convert from degrees to arc seconds. So 2.91 times 10 to the minus 9 degrees times, I need to do this in 2 steps, 60 arc minutes, and one little line like that means arc minutes per degree, times 60 arc seconds, 2 little lines like that is arc seconds, per arc minute. Okay, so I do this calculation and I'm going to find that the angular size is equal to 1.05 times 10 to the minus 5 arc seconds. And this is our answer to part B. Now we have to think about what this means, write a sentence about it, and 1.05 times 10 to the minus 5 arc seconds, let me just write that out with zeros. I'm just going to sneak it in down here. 0.00001 and then 0.5. That's really small. What this means is that this is still not visible from Earth with even our best telescopes. This thing is too small. So that's the interesting thing about this answer, and that's what I would probably put in a sentence. So hopefully this all worked out okay. Thanks for viewing the video. Sorry about the bad handwriting and some of the mistakes. I will get better with practice. And we'll see you in class. Thanks again. Bye.